Hello everybody. This is a video on the Intelligent Plasma Ball, nicknamed the Telligent, and I would like to suggest before you go any further and watch this video, is that you download the PDF off the www.aurorasky.website, which is also listed in the video caption, so you'll have the address there. And use it as a follow-through or a come along with respect to what I say and what is presented in the opening quick start. Help clarify one another. So the reason why I have the camera so close is because that's only a 1-inch liquid crystal display, and the camera is very finicky and hard to focus, and you can't even read the display if I put the camera any farther away. I have a very basic video scheme here. I use Mint with a very simple camera, and I'm using what they call the Cheese package, which is a standard image capture package. Not very sophisticated, but it works. I've done all my videos this way, and I'm going to see if we can get through this one the same way. So I'm going to start and stop occasionally, just so I can get my act together on where I'm at in this presentation. But the first thing I want to do is to show you the plasma ball a little bit better close up. Looks very familiar, should look very familiar. There's a toggle switch down here now versus a slider switch. There's a whole new board in here. The board also has its mask posted on the website and the schematics, so you can see the board. You can duplicate the board. You can do whatever you want with it because it's all open source. But this part of the plasma ball looks identical to the 6-inch plasma ball that's already advertised on the website or shown or displayed on the website. And it functions the same. When the switches are down, it runs on the internal components. When the switches are up, it runs on an external source such as a Spooky 2 or any other function generator. This side here consists of a display, a rotary knob, a continuous rotary knob. It's very similar to what's on a lot of the function generators, and a single push button switch. Additionally, of course, the power goes in here, right where my finger's pointing now. So without further ado, we're going to plug in the power and get this baby up and running. And I'll have to turn on the switch. And the first thing you'll see is coming to life is the screen. Now here it's just going to be a matter of letting the unit autofocus on the screen. And we got it. And this is how most of the presentation will be shown. Just so I can get that screen in view. The unit as it comes from Aurora Sky has this very same identical screen. Presently it does, it's the same. And I'm going to go over it piece by piece. In the up here in left hand corner, there is a word called setup equals 0. If you follow on the Intelligence Plasma Ball Quick Startup Sheet, PFD, you'll see that I make it a lot clearer. I actually print the screen out. And it says setup equals 0, frequency reads equals 1. To explain that, there are 5 setup screens. We are on the 0, the first setup screen. Setup screen 0 allows you to select one of 50 different memory groups, and each memory group contains 2 frequencies and 2 duty cycles. The 2 frequencies, of course, represent channel 1 and channel 2, and they're labeled F1 and F2. And the duty cycles correspond with D2 and or D1 and D2. All right. Right now, it is set in a simple frequency mode. So the upper frequency is 34922 Hertz or 39.922 kilohertz with a duty cycle of 20%. There is a limitation on the upper frequency duty cycle, and the software monitors it, so you cannot override it. It will go from 1 to, I believe 1 to 25%, and typical values in there would be 10, 15, and 20. You can push it a little harder by going to 25, and when you get down to real low frequencies, you need to have very small duty cycles, literally down in the 2, 3, and 4, and 5% range. More on that possibly in another video. We're only going to have time to get one done today, and we'll probably break this one single video up into 3 or 4 before I'm finished. I'm going to explain a couple of functions right now, and the first thing you'll see is a small underline under the 0 on setup equals 0, and if I press the red button where my finger is at right now, you'll see that cursor jump over to frequency reads equals 1, and if I press it again, it'll snap back to the setup equals 0. So that's all this cursor will do. It'll go back and forth on this screen. When it's under the 1 in reads, I already have 50 channels pre-recorded in the memory here. Some of them really don't do much, but right now we're in channel 1 or memory position 1. I call them frequency groups because there's actually 2 frequencies and 2 duty cycles allocated to each memory channel. So this frequency group has got the second frequency set to Showman's Residence 7.83 and with a duty cycle of 50%. To start the plasma ball, right now I know it's in a protocol called, or in a mode, not a protocol, but in a mode of simple frequency, so it will run whatever is on the screen when it's in simple mode. And if I press the plasma ball, and hopefully the camera doesn't get flaked out by the electric field, well, it doesn't, and it's flashing away. I'll just back this up a little bit, and you can see the plasma ball flashing away. See if I can get focus again. Hopefully it'll find its focus. There it goes. It's found its focus. And so it's in the running screen. And with the running screen, I'll explain that too. And this is a little out of order from the quick start, but that's quite all right. I'm here. This is where I'm going to talk about. This is what I'm going to talk about. Presently, it is. Oh, it's changing. I have it set up for a different protocol on this particular ball. I am going to stop this and not restart this presentation, but to reset. And you're gonna, I'll come back and explain what I'm doing, but I'm going to go back to setup, and I'm going to go to screen 2, and I'm going to change the mode to simple. You can see the cursor just jumped underneath mode 2. I know it's not perfectly clear, but I'm going to change that to a 1. And then it'll go back. And I'm going to hit the setup to 0 again. Voila. And now I'm going to run that simple screen frequency. I was in protocol. I was running a sequence of frequencies, and I didn't intend to do that. But I switched plasma balls. And I didn't check to see what the last program or setup I was running in this particular plasma ball. Okay, back where I was last, we have a frequency, a primary frequency of 34922. By the way, that is a Fibonacci series or golden mean ratio derivative. I'm not going to explain that. That's out of that's off topic for right now. And it's got a Showman's Residence. Ooh, I'm not in frequency 2, so I'm going to go over frequency 1. And it's got a Showman's Residence running at 7.83. And if I press the button again, it's not only flashing, but it's running the primary when it's on. You want to see it? There it is. It's flashing to me. The camera can't catch it very well, but it is flashing to me. It's flashing at 7.83 hertz. This running screen has a T, and that number changes. 905. It's explained in the PDF, and what that number is, it's the temperature of the MOSFET that's driving the plasma. And that's very important because the internal circuitry cannot overdrive the plasma, but an external circuitry running from a spooky, you can certainly overdrive the plasma MOSFET, is what I meant to say. Complete sentence would be plasma ball MOSFET. The MOSFET is a power driving FET transistor that will turn the plasma ball on and off at the selected frequencies. And if you run externally, you'll see right now it's about 900, and that just represents to the software roughly the ambient temperature. And you'll see it's dropping slowly. It's dropping to 899, and what that's indicating is that we're running and the plasma ball is warming up that FET MOSFET, warming it up, and it'll probably settle out and stay oscillating, or not stay oscillating, probably stay at a temperature between 8 and 900. When it starts to get lower than 800, it's starting to get really warm, and if it gets down to 725, a too hot will display on the screen and shut the plasma ball down. This won't happen from running it with the internal Arduino and the software and the hardware. You'll only get that 725, get it too hot, if you use too large a duty cycle and you're running from an external function generator. Okay, the number, let me see if I can get it to stay. I know I can watch it flickering, going in and out of focus. The number equals 1. That means we're running the very first frequency that's in the 50 memory database inside the Arduino. And we're running number 1. When you're running in protocol modes, it'll change. You'll watch it change from 1 to 2 as you increment through the various frequencies, because you're running a string of frequencies in what I call protocol mode. And when you're in sweep mode, it will also increment to the number of frequencies that the sweep has figured out it is going to sweep through. And I'll explain that a little bit more a little bit later in this video. I'm going to stop it, go back to the original screen, and we're going to go into more detail on the other 5 screens within the plasma ball. This is a 13-minute, 25-second video. I'm going to cut it here, and we're going to call this video 1, and we will start video 2 in just a few minutes.